Solving simple trigonometric equations. The unit circle. So the unit circle represents a circle that has been divided into 4 quadrants, and therefore we've got the first quadrant here, which represents angle 0 degrees all the way to 90 degrees, and then there's the second quadrant, which is 90 degrees to 180 degrees, and then there's the third quadrant, which is 180 to 270 degrees, and then the fourth quadrant, which is 270 degrees to 360 degrees. And the purpose of the unit circle is to summarize the behavior of angles as far as sine, cosine, and tangent is concerned. For instance, when we consider the word cast, this is what it means in summary. That in the first quadrant, both the sine, the cosine, and the tangent are positive. And then in the second quadrant, it's only the sine that is positive, represented by the letter S, and therefore the cosine and the tangent are negative there. And then in the third quadrant, it's only the tangent that is positive, and therefore the sine and the cosine are both negative. And then in the fourth quadrant, it is the cosine that is positive, therefore the sine and the tangent will be negative. So when you talk of cast, we are talking about all, and then here there is sine, and then there is cosine being positive, and then there is tangent being positive on this other side, and therefore it leads us to have the word cast, that is moving in anti-clockwise direction from the fourth quadrant to the third quadrant, to remember what is needed there. Trigonometric identities. There are 2 trigonometric identities that we are going to consider here. The first one being sine squared x plus cos squared x is equal to 1. And this will mean sine x multiplied by itself plus cos x multiplied by itself to be equal to 1. And the second one is tan x to be equal to sine x divided by cos x. And how do we derive these 2 identities? Let's consider the following. Let's consider a unit circle of radius 1 unit. We can consider another radius here in form of a diagonal to this diagram, which will also be 1 unit like that. And the aim is to come up with this right angle triangle here. So I can label the center O, and then I can label this point here to be the point A, and the point at the circumference to be the point B. And this is where we find angle x degrees. Therefore, considering the laws that apply to a right angle triangle, we've got the SOHCAHTOA, where we talk of sine will be equal to opposite of hypotenuse, the cosine will be equal to adjacent of hypotenuse, and the tangent will be equal to the opposite over the adjacent. So we are going to consider here that sine x degrees, the angle here, will be equal to the opposite, which is AB, divided by the adjacent, divided by the hypotenuse, which is OB. And then, since we've considered that OB is equal to 1, we are going to have sine x will be equal to AB divided by 1. And therefore, when you multiply both sides by 1, you're going to get that AB will be equal to sine x. And therefore, I can represent it in my diagram So AB is equal to sine x. And then when it comes to the cosine of this angle, we're going to say here that cos x will be equal to the adjacent, which is OA, divided by the hypotenuse, which is OB. And then we know that OB is equal to 1, so we're going to have 1, and then there's OA to be equal to cos x. And therefore, when you multiply both sides by 1, you're going to get the size of OA to be equal to cos x. And therefore, I can represent that in my diagram as cos x degrees. Therefore, considering the second law as far as a right angle triangle is concerned, which is the Pythagoras relationship, we are going to say that AB squared plus OA squared will be equal to OB squared. And AB squared is equal to sine x multiplied by itself, that means sine squared x, plus cos x multiplied by itself, that means cos squared x, to be equal to 1 squared, which is equal to 1. And therefore, this is the first trigonometric identity that we've considered there. And therefore, in the second identity, we can consider that the tangent of this angle, which is tan x, will be equal to the opposite, which is AB, which we've already considered as sine x, divided by the adjacent, which is OA, which we've already considered as cos x. And that is how we derive the two trigonometric identities. Questions. Number 1. If x lies between 0 degrees and 360 degrees and sine x degrees will be equal to 0.2588, find the two values of x. 2 marks. Solution. So we are going to consider that sine x degrees being equal to 0.2588, we are going to find the value of x. And the value of x will be found by finding the sine inverse of 0.2588. Therefore, the value of x will be equal to 30 degrees. The next step is to consider this angle on the unit circle. We know that the sine of x was positive, so according to the quadrants, x will be positive in the first quadrant and also in the second quadrant. So in the first quadrant, the value of x will be theta, so therefore x will be equal to 30 degrees, and the next angle will be in the second quadrant, which will be 180 minus theta, and that will lead us to getting 180 minus 30, which will be equal to 150 degrees. So the two values of x will be 30 degrees and 150 degrees. Question 2. Solve the equation sine into bracket 2x minus 30 degrees will be equal to a half for 0 degrees is less than or equal to x, and x is less than or equal to 360 degrees. 3 marks. Solution. Since the sine of 2x minus 30 degrees will be equal to a half, we are going to consider that 2x minus 30 degrees will be equal to the sine inverse of a half, which I can write it as a decimal number as 0.5. And the sine inverse of 0.5 will be equal to 30 degrees. And then we consider on the unit circle that since the sine of 2x minus 30 degrees was equal to a half, we are going to consider that that is a positive number, and therefore it will be found in the first quadrant and also in the second quadrant. We can consider several values of 2x minus 30, which will be equal to 30 degrees that we've considered here. So the first angle will be 30 degrees, and then the second angle, which will be found in the second quadrant, will be 180 minus 30 degrees, which will be equal to 150 degrees. So we can consider several values of x minus 30 degrees. So we've got 30, we've got 150, and then you will not consider an angle in the third and the fourth quadrant, so it means you have to make another round. So at this point you are back at 360 degrees, and then you are going to add 30 because we need another angle in the first quadrant. So that will be 360 degrees plus 30 degrees, which will be equal to 390 degrees. And then after 390 degrees, the next angle will be found in the second quadrant. So we already had 150. We can consider that this will be 360 plus 150 degrees here, which will lead us to getting 510 degrees. Now that we have these four angles, it can be more depending on what we want to get. We can now consider finding the value of x, which is supposed to be between 0 and 360 degrees. So we'll start by saying here that 2x minus 30 degrees will be equal to 30 degrees. And therefore 2x will be equal to 30 plus 30 degrees. So 2x will be equal to 60, and therefore when you divide both sides by 2, the first value of x will be equal to 30 degrees. The second value of x, we are going to consider that 2x minus 30 degrees will be equal to the second angle here, which is 150 degrees, and therefore 2x will be equal to 150 plus 30 degrees, and therefore 2x is equal to 180 degrees. And when you divide both sides by 2, you're going to get the value of x to be equal to 90 degrees. The third angle, we are going to consider that 2x minus 30 will be equal to 390 degrees. And therefore 2x will be equal to 390 plus 30 degrees. So 2x will be equal to 420 degrees. And when you divide both sides by 2, you will get our third angle to be equal to 210 degrees. And the last angle we can consider is 2x minus 30 degrees to be equal to 510 degrees. And therefore 2x will be equal to 510 plus 30 degrees. So 2x will be equal to 540 degrees. And then when you divide both sides by 2, we get the value of x to be equal to 270 degrees. So these are the only values of x that we can find in that range. So if we make another revolution, we are going to get values of x that will be more than 360 degrees. Question 3. Solve the equation 3 cos 2 into bracket x minus 20 minus 1 to be equal to 0 for 0 degrees is less than or equal to x less than or equal to 360 degrees. Solution. So let's rewrite the equation. 3 cos 2 into x minus 20 minus 1 to be equal to 0. So the first step that we are going to consider is taking this negative number to the other side of the equal sign. So we end up having 3 cos 2 into x minus 20 to be equal to 1. And then the next step is to get rid of the coefficient here by dividing by 3 on both sides. So we end up having cos 2 into x minus 20 to be equal to a third. And then 2 into x minus 20 will be equal to the cos inverse of a third, and therefore 2 into x minus 20 will be equal to 70.53 degrees. We know that the value of the cosine of 2 into x minus 20 is a third, which means it's a positive number. The cos of an angle is positive in the first quadrant and also in the fourth quadrant. And therefore, considering different angles of 2 into x minus 20 here, we are going to consider that theta will be 70.53, that means in the first quadrant, and then in the fourth quadrant we are going to have 360 degrees to subtract 70.53, which is equal to 289.47. And then at this point we move to the first quadrant. We are making the second revolution. So at this point, this is 360 degrees. We are going to add 70.53. So we can get another angle here, which is 430.53 degrees. And then we can also add another angle, 360. We move all round to 720. And then we subtract 70.53. You're going to get the angle 649.47. The last step will now be to find the value of x that will fall in this range. So the first angle will be, we consider 2 into x minus 20 to be equal to 70.53 degrees. So therefore 2x minus 40, as I open the brackets, will be equal to 70.53 degrees, and therefore 2x will be equal to 70.53 plus 40 degrees. So 2x will be equal to 110.53 degrees, and on dividing both sides by 2, we are going to get the value of x to be equal to 55.27 degrees. The second angle in the range, we are going to have 2 into x minus 20 to be equal to 289.47 degrees, and therefore 2x minus 40 will be equal to 289.47 degrees. So 2x will be equal to 289.47 plus 40 degrees. 2x will be equal to 329.47 degrees, and therefore when you divide both sides by 2, you are going to get the value of x to be equal to 164.74 degrees. For the third angle, we are going to consider 2 into x minus 20 to be equal to 430.53 degrees, and therefore 2x minus 40 will be equal to 430.53, and then 2x will be equal to 430.53. we add 40 degrees, so 2x will be equal to 470.53, and when we divide both sides by 2, we get the value of x to be equal to 235.27 degrees. Let's see whether the last angle here will also fall in the range. So we're going to have 2 into x minus 20 to be equal to 649.47 degrees, and therefore 2x minus 40 will be equal to 649.47 degrees. 2x will be equal to 649.47 plus 40 degrees. 2x will be equal to 689.47 degrees, and therefore when you divide both sides by 2, you're going to get the value of x to be equal to 344.74 degrees. So these are the 4 angles of x that fall in the range.